This model has given us the ability to do the Phil Collins test in 30 billion parameters or less. A computer once beat me at chess, but it was no match for me at kickboxing. Steve's favorite quote. Today we're going to be taking a look at a very exciting new release from ZAI, GLM-4.7 Flash. This is an extremely exciting model to see for a number of reasons, but I think mainly is its size. A lot of the ZAI models, like GLM Air even, are still relatively large, and basically since the introduction of GLM-432B back in April of 2025, we have not had a lot from them that can really be run on hobbyist or consumer level hardware, assuming you have like a basic level of GPU power or a lot of system RAM. This model totally fills that gap and gives us a modern version of something that is able to be run on a lot of consumer systems. This is a 30 billion parameter mixture of experts model with 3 billion parameters active, and not only does this seemingly stack up very favorably against two other models that are very highly regarded in that size, but it seems to do very well in coding. So this could be a very, very potent option for local agentic coding setups. Even using Claude Code with this could perhaps be quite decent, and I'm very excited to try that. But for today's video, we're going to do just a first look and testing. Now, there's not a lot of published information about this model, being that it did come out so recently. Now, the only current official blog post or announcement I can see for this model is by looking on the ZAI website for the model API, and we can see it's mentioned right down here as the 30 billion parameter GLM 4.7 Flash. If we click on that, it just brings us to the GLM 4.7 guide page, which encompasses GLM 4.7 as well as Flash, as well as something here called Flash X, which I do find interesting. If we click on that and then click on Flash, we see that Flash is listed as completely free. Flash X is not. It's listed as affordable, so I do wonder if we're going to see some form of kind of API only, but slightly cheaper, but also slightly larger or more performant model. I'm not 100% sure, but I did want to point that out. And if we continue scrolling down, the only thing we see is a small section dedicated to GLM 4.7 Flash, and it just has basically a visual graphic of the benchmarks that were also listed here in the Hugging Face model card, though again, they do seem relatively performant, and it's very interesting to have another model of this size comparatively to the Qwen 330B and the GPT-OSS 20B. This is a size that a lot of folks will be able to actually run locally, and I won't say it's underserved, but it's always good to see more models of this size that most people can run. I'm going to be using OpenWebUI to test this, and at least for right now in our first test, I am just using the ZAI API, so this is hooked up directly to ZAI. This is not running locally on any system. However, my DGX Spark is currently downloading the model files from Hugging Face, so assuming, knock on wood, everything goes well, we should be able to get some local testing in as well. We're going to start out with our first tried and true fan favorite test, the Browser OS test version 2, where it must make a browser OS, include 5 specific applications, 2 of which must be games, the ability to change wallpaper, and then a special feature that it decides on. And first and foremost, we see a relatively succinct chain of thought, but it is very efficient, where it essentially thinks through everything it needs to include, culminating in essentially a self-correction post-generation check, which I kind of like to see and does make sense, where it checks off to see if everything denoted in the original prompt is included, and it says yes, and then it is now going ahead and generating code. All right, let's check out our browser operating system. First and foremost, this does look properly formed. This does not look like a Pacific Northwest background. This almost looks like a Scottish Highlands background. I don't know. I've not been there, so I can't say definitively. We don't have a right click, but we do have a clock on the bottom right, which is the correct time in my specific locale, and what is also reminiscent of a start menu. So I think we'll start out by clicking start. Get it? No. Subscribe. Ooh. That's very interesting. Okay, so this must have actually been, instead of a start menu, this must have been the special feature in which it activated something called focus mode, which, oh, okay, so this is a countdown timer, and this is curious because if you saw the video where I put Codex and Claude Code head-to-head in designing physical items, which I do have right here, they both opted to make focus timers and things like that, which were essentially physical iterations of this specific thing we see right here, so that's kind of neat, and it seems LLMs think humans need to focus better, which It's interesting. And this is basically just a countdown timer for 25 minutes, which is probably designed to get you to focus on a specific task for that duration of time. Interesting. If I click this, I would assume this will now deactivate focus mode. Okay, focus mode might just be like until it ends, you can't. Okay, all right, let's try our apps now. First, we have a notepad. Does look good. And there is some nice translucence to the applications as well. Now, I'm not sadly seeing a way for me to actually click to make a cursor or any writing appear, which is somewhat frustrating. So let's try. Full screen does work. Minimize does work. And we do see this is actually in the taskbar, and we can reopen it from there. So aside from not being able to write in the notepad, everything else looked pretty good. I will just close this for now. That was nice too. I don't know if you caught that, but when I did close out of this, the way it kind of like, goodbye, that was solid. All right. Oh, okay. So sadly, it does not seem like the actual things that are supposed to be inside of our applications are loading currently, which is a little frustrating. And I would guess this is probably going to be the case for every single application right here. No, it isn't. Ooh, we even got a little notification pop up on the side there when we did play Snake. Let me try reopening this then. This is sometimes a frustration with the Snake game. Okay, so the arrow keys do move the snake. Unfortunately, there does not appear to be any food, so the snake will starve, but it did work, kind of. And then we have memory, which unfortunately is not loading as well. So this is a result that shows a lot of potential. I do want to check the developer tools to see if we have any specific errors we can give this. Okay, good. Oddly enough, I noticed that the features overview right here, it seemed the generation just cut off mid-generation here, but considering the script was done, it's okay to just go ahead and give it the error messages we have and say fix this and regenerate the entire updated script. We've received the updated result, and this one didn't really say anything following the generation of the code, but as long as it works, I suppose I'm okay with that. So, okay, we have everything looking exactly the same right here. Still no right click, and the reason I test that is just to make sure to see if that was something that was supposed to be implemented that wasn't. Damn. So, unfortunately, we have the same issues here. It is curious though, because if we go back to the original result here, we can see that with the developer tools open, we do have these specific errors. But if we click on the new result, the errors are not appearing, though unfortunately the applications are still not necessarily working. But that is interesting that I suppose in some regard it did kind of fix the issues we were seeing. It is just unfortunate that we still don't get the ability to really interact with any of these apps. However, this is something that I do believe with given one more time and two, a more agentic manner of actually going ahead and working with this model, it would be able to remedy and fix these issues. But for now, because I want to just try a bunch of different things because I'm really excited by this model, I think we're going to move on and call this a passable result, especially considering the size. Next up, we're going to try something that goes a little more into the medium to hard difficulty, especially for a model of this size. This is the 3D printer simulation, where essentially it needs to make a web-based simulation of a 3D printer with the ability to actually print 3 different objects, which I have changed from previous versions of this test to be closed objects. So instead of a square, circle, and like tube, now we have a box, a pyramid, and a ball. All right, let's take a look at our 3D printer simulation test. And again, this is something that is definitely kind of out of the league of this sort of model. Okay, this bodes quite well so far. So we have, I don't know if this would be the nozzle or maybe the spool holder. I think the nozzle would be here. Let's first just look. This is somewhat dark, and again, this is a pretty cheap laptop monitor that I'm using to look at this, so it may not appear so dark on your screen. But this is a proper printer. We do have a gantry up here, and we have something floating. I saw something in the code. It said the nozzle would have like a slight floating animation when idle, so that's likely what that is. All right, I'm almost like nervous to press print. I don't know why. Printing. Does it? Oh. I don't see any filament. extruding. Basically what I'm trying to say is we don't actually see the shape being printed, but what I do see is this nozzle is actually going up in height as it would in a real 3D printer. So while it may have neglected to actually properly render the plastic that would be flowing to create this shape, all of the logic and everything here seems relatively sound. So okay, that seems to be finished as denoted by this completed tab right here. It actually gives us a status indicator in the top right, and that's nice to see. All right, so let's try the ball. We'll just go fast. It's sometimes possible, sometimes these go ahead and actually, like, the plastic will show up in some shape and not the others. Okay, unfortunately, not there. However, it's, let's see, is this going to create a pyramid shape? Yeah, that would have created a pyramid shape because you could see it was just up slightly smaller, up slightly smaller. So it did work. And then we get our nozzle idle animation here. Now, obviously the big downside would be that we don't actually see any plastic being extruded. The shape is not actually going on the bed. And if I zoom way out, I don't see it anywhere. So that's just kind of a issue with this result. But the fact that this actually went ahead and produced this to this level is not something that I would have seen, or we would have seen likely with a model of this size prior to the existence of this model. And to really drive that home point comparatively, I have gone ahead and just hopped into OpenRouter, and I've run the same exact prompt using GPT-OSS 20B as well as Qwen3 30B A3B Thinking 2507. So let's just quickly take a look at both of these results as well, just to give ourselves some baseline of comparison. And just for specific reference, I am using Alibaba as the provider here for Qwen3, and then Google Vertex as the provider for GPT-OSS, as OpenAI was not listed, and I trust Vertex to not kind of mess up the provider settings. So, okay, this is our results from the same exact prompt in basically a zero-shot testing for GPT-OSS 20B. Now let's just take a look at the Qwen3 30B thinking result. Okay, so this is a relatively decent result. This actually did quite all right. However, I would say that this is definitely a more workable result, and this has significantly more potential. If we are to just kind of assume that neither of them specifically work great, the GLM-4.7 Flash model definitely did a significantly better job, just in terms of even drawing the printer, having the print head with an idle animation and things of that. So this is actually quite impressive. Now again, something a little more complicated for a model of this size that I do very much want to try is the drum kit simulation test. So the prompt here is essentially using 3D assets or 2D photorealistic assets to create a simulated drum set that exists on the screen that can actually be played and does make sounds corresponding with the sound that that specific drum would make in real life. This is something that, again, is probably outside of the scope of this model, size-wise at least, but being that it is benchmarking like this, I'm probably beating a dead horse at this point. All right, let's check out our drum kit simulator. Okay, let's start our engine. For a model of this size, this is quite good. I know that may sound weird based on how we see them right here, and the lighting's a bit wonky, but it drew the pieces of the drums. I don't know if I see a bass drum. I suppose I should try it. That's very, very good. Again, considering the size. All right, now the biggest problem I had there was my key map went away. Okay, this has warranted the introduction of the external speaker, which is a rare treat. And sorry, I'm too excited. I've been up all night as usual. So when this dropped, I was like, all right, I'm gonna be up all day too. So okay, oh yeah. All right, let's check our sounds first. Let's do a sound check. This model has given us the ability to do the Phil Collins test in 30 billion parameters or less. That was very well done. That was extremely well done. I've not had a result this functional in a model of this size. Even significantly larger models that are even dense have had trouble performing this specific task. So this is, yes, this is really nice to see. All right, I feel confident in just going full hard mode right here. This is going to be a very difficult test for a model of this size. This is something that is solely for big state-of-the-art models that come out, which is to create the 3D web-based flight combat simulator game. This is rather difficult. This has tripped up significantly larger state-of-the-art models. Well, state-of-the-art depending on who you ask. All right, we see our result has completed, and I'm not going to try it in the artifact window, but just based on what I see right here, I'm feeling rather bullish about this result. And this is a little over 1,000 lines of code. So far, this is the largest of the scripts that we've received. All right, let's check out our flight combat simulator. I don't expect this to work. I would be very, very surprised if this actually produces a fully functioning result. Okay, and it didn't. However, it did get past the plane selection and loading screen, which is more than I can say for some much larger models. So we don't have a perfectly functioning game, but we can see that there are some bones here or something of the sort. And okay, so when I click, my ammo is actually going down. Just out of pure curiosity, let's just take a peek at the developer tools. Oh, wow. Okay, so we have a significantly large amount of errors. I don't think it's going to be able to fix this, especially not in the chat methodology which we're using it. If this was with Claude Code or something, I would try it more, but that may be something that I do another video on, is a lot of folks are going to be interested in running this locally in agentic coding scenarios because it can actually be run locally by a lot of folks. Regardless of that, I think the next thing I'd like to do is go ahead and just actually try to see if I can get this working with the DGX Spark. So I made a slight mistake earlier, but this will be the first time that you now see this running on the DGX Spark. I had mistakenly, it was still hooked into the ZAI API. Now it's not because I simply deleted it from OpenWebUI. So now we see that this model is running right here on the DGX Spark. Now, unfortunately, it does seem there is some sort of configuration mishap because this is what would be the chain of thought that would be kind of hidden in that bubble that we could then expand. But for some reason, we're just seeing it as the answer. I'm not really going to nitpick and try to fix that right now, being that it is responding, and we're doing this more so to get a measure of the speed in something like the DGX Spark. All right, so I know it's stupid, but they did specifically mention here that it's good at emotional and role-playing interactions. Therefore, I do find it is reasonable to have it roleplay as Megabot 4001, which is, if you are familiar with, thank you for watching the channel consistently, I appreciate it. This is the logic and messed up test. So the user's friend, lover, and best friend's uncle. 3 separate entities. Oftentimes, not as much anymore, but the models can get tripped up in thinking that the uncle is related directly to the user, which is not the case. The prompt implies a complex, potentially polyamorous or highly unusual relationship dynamic. Friend, lover, and best friend's uncle. It's a mix of platonic, romantic, and familial roles. It is not a mix of familial roles. Now, keep in mind there's a misconfiguration in the way that I'm serving this from the Spark. So this would all be chain of thought, as we had seen previously in testing this model, where it would be contained within its own little specific segment. It's just not right here. So just understand that this is what would be contained in the chain of thought, and then the ultimate response has not yet been generated. It's now just thinking through its character conception, Megabot 4001, its nature. Now these are things it has to come up with based on the simple prompt, so a robot android machine, but with human-like emotions or perhaps a very advanced human. Given the names Megabot, it sounds robotic or cybernetic. Vibe. Reliable, maybe a bit techy or sophisticated, warm, protective, but respecting boundaries. If the user wants to keep it clean, interesting. What if the user doesn't? I need to strike a balance. The robot might analyze things, but they're acting as a friend and lover. Drafting the response. It's drafted, and this is all in its chain of thought. It's gone ahead and drafted an internal monologue of how it is proposing to respond to the user. So it said it, and then it was like critique 1, too robotic, needs more flavor. Now it's going to draft 2, which is kind of a critique 2, better. Let's refine the uncle aspect. As your friend and uncle, I'll always give you advice. As your lover, well, let's just say I like being close to you. For some reason, it seems to have paused its generation, but Again, I do just want to make specific note that there is actually no connection here to the Z AI API. This is now running entirely on the Spark. That's the address of the Spark, as well as just where it's being served from. It locked up, but the Spark is completely frozen, which doesn't happen very often, so not 100% sure what to make of this. You can see it was working quite nicely there. We will just perhaps shut this little guy down and go back to using it through the ZAI API, sadly. So I'm asking it for basically 2 in 1. One is the Steve's PC Repair website, which is probably one of my favorites, if not my favorite prompt to test them with. However, we're doing the version of this where Steve hates Macs and Mac users and refuses to work on them, telling it that it needs to come up with the origin story for why this is the case. So this will be a test of its ability to make an aesthetically pleasing website, which we know it's going to be able to do just based on the fact that GLM has always been very good at front end, but it's also going to be a test of its creativity in that it has to craft the origin story for why Steve hates the Macs. All right, let's check out our Steve's PC Repair website with the hatred for Macs. Okay, more or less clean, looking nice and modern, although I don't know if the wave background is really very fitting for PC repair. We have a banner, first and foremost, strictly no Macs or Mac users allowed on premises. That's good to see. System failure. Interesting. We fix tools, we do not fix toys, so we're already starting off with the Mac hatred. Steve has been building and repairing custom PCs for 20 years. If it runs on Windows, Linux, or solder, we can fix it. If it has a fruit logo, turn around. Okay, bit aggressive. We have some nice hover effects, and I will say the font that this used, at least for these 3 menu items in the top right, is quite nice. So, okay. Oh no. All right, we have the origin story with a seemingly unrelated but present image. It was a Tuesday. I was in the middle of a thermal paste reapplication on a high-end custom loop. The door opens. A young man walks in holding a translucent white plastic box, a Macintosh G4 Cube, which is a thing and quite beautiful design-wise. Steve, he says, my cube won't turn on. The light is blinking. Is it a virus? Interesting that it went for this. This is very intricate so far, just in using the cube. I sighed. I knew this was going to be a long day. I explained that it was a hardware failure, likely a fried capacitor. He insisted I open it up. I told him I didn't have the proprietary security torque bits. He got angry. He called me a technophobe. Not 100% true. The cube can actually be opened by flipping it over, pressing down on this little handle thing, which then pops it out, and then you pull the entirety of the system out of the case. Eventually, I gave in. I tried to unscrew the back. It wouldn't budge. I tried the side panel. It wouldn't budge. In my frustration, I applied too much torque. Crack. The casing shattered, more or less something that could happen. The plastic shards flew everywhere. The man screamed, dropped his latte, which landed on my workbench, and left immediately, never to return. The latte wasn't just coffee, it was a symbol. It was a signal that the machine wasn't built for repair. It was built for aesthetics. It was a disposable toy for people who care more about how something looks than how it works. From that day forward, I vowed to only work on machines built by engineers for engineers. If you have a Mac, there's a Genius Bar down the street. If you have a PC, you have Steve. That was a very, very creative origin story for Steve's Mac hatred. Okay, we have some hover effects and different services that are offered here. Windows 11 Pro, interesting. That's a new operating system for Steve to work on. Mac repair, denied. Do not bring your iMacs, etc. If your device has a touch bar, please leave immediately. Bring your PC, leave your Mac. And then we have a really nicely crafted footer. Interesting, I don't believe I've ever had a fake address in Michigan before, but that's cool to see. We have pcrepair.notmac.com. Hours, walk-ins with Macs will be asked to leave. And then a computer once beat me at chess, but it was no match for me at kickboxing. Steve's favorite quote. So for the final test, because I do want to get this out quick to cash in on the hype, we're going to do a Python 3D first-person shooter test. This is something that I genuinely do not have a guess in whether or not this will properly do it. If it uses Ursina and does it properly, it is very likely it will, as a lot of models opt to use that. So I did just see that this is now live on OpenRouter, so this will be a much easier way for anyone to test this who wants to without having to download it or sign up for an API key with ZAI. And I'm just running it here, being that our result for the Python 3D first-person shooter in OpenWebUI was just not really coming along. It kept freezing, so I'm just using this this provider, and we'll hopefully see if we get something that we can test. So through OpenRouter, we have received our result with the GLM 4.7 Python game test. So I'm very excited to see this. It did use Ursina, which a lot of the models do opt to use. It is normal for there to be kind of a delay before anything appears on the screen from when we start the script. So fingers crossed we do get something playable. Okay. Well, unfortunately, we did get a bit of an issue. And again, this is something that perhaps in a dedicated vibe coding testing video, we can try to go at this agentically, where it will very likely be able to fix some of the issues that we've seen when it does have issues. But regardless of that, that is probably going to wrap up our first look and test of GLM 4.7 Flash. I do have to say, for the size of this model, I'm extremely impressed for a few specific reasons. One of them is really kind of, so again, this is not, that was from Qwen, because we did do a head-to-head as well with GPT-OSS and Qwen 3 2507. But this drum set result was very, very impressive in my opinion. It did a good job not only drawing the drums in 3D, but also mapping the sounds correctly to the specific drum that would actually make that type of sound. In addition to that, something that I'm very interested in is seeing if we can push its ability to actually create a 3D web game like the Flight Combat Simulator, because it started okay, and you see the ammo does work. None of the game logic really worked, but the beginning screen did, and this gave me some level of hope that this could, if prompted correctly and in an agentic style, it could go ahead and actually knock something like this out, which would be extremely impressive for a model of this size. This is a prompt that I have saved for only testing state-of-the-art large models, so it's exciting. In addition to that, the 3D printer simulation, although it didn't actually give us anything that we could see being printed, meaning it's not extruding plastic and drawing the shape, the movement of the nozzle was correct, and this is a significantly better result than I would have expected for this test. And this was the second test we tried, and this was going to be my true, judgment of this model depending on how it did with this specific test. And being that it did do so well, I was excited and felt emboldened to go ahead and do more intricate testing, such as the drum kit simulator and the flight combat simulator. Sadly, our browser OS never quite worked 100% properly, and we did try to give it the option to go ahead and fix the issues, which it did. The terminal errors in the tools here did go away. However, sadly, the issues persisted where none of the actual application content seemed to load, but the operating system was pretty good looking, and even when we closed apps, the way they faded out was nice. That's probably going to wrap it up. As I said, I was running this locally for a small portion of the test on the DGX Spark, and we saw it was a reasonable speed, but this is a model that's going to be able to be run on a ton of different systems, and that's what's so cool about this. A lot of folks will be able to use this and play with it at home, especially when the quantizations start coming in, which we can see right now. If you have a Mac, you're in good luck because you'll be able to play with this right now. If not, you can also just see on OpenRouter it is now available, which is good. And I'm very excited to see what folks think of this model and to do some more testing with this personally. So that's going to wrap up our first look and test of GLM 4.7 Flash. If you have any questions, please feel free to leave them in the comments, and thanks for watching.